Hello and welcome back to part 2 of section 7.3. We're still looking at multivariable linear systems. So far, the 3 examples that we've looked at have been what we call square systems. Now, a square system is where the number of equations is equal to the number of variables that are involved. A non-square system, which we're going to look at here in just one second, means that we have a different amount of equations as opposed to the number of variables that are in those equations. So example 4 is a prime example of a non-square system. As you can see, we have 2 equations, but we have an x, a y, and a z, or 3 variables. So this is what we call non-square. The process for solving this is still similar, so let's go ahead and begin. In this equation, our top equation is going to be left alone because of that coefficient of 1. So I'm going to rewrite x minus y plus 4z is equal to 3. And now I have to come up with a new second equation. Well, I notice that I have a 4x here and a 1x here. So I'm going to go negative r1 plus r2. So that gives me negative, and that should be a negative 4r1. So negative 4x plus 4y minus 16z equals a negative 12. And then I still have my 4x and my negative z and 0. So my new second equation then, my x's are going to cancel, and I have plus 4y minus 17z equals a negative 12. Because I can't come up with a new third equation, and this here is my new second, I need to take my new second and solve for y. So when I do that, I end up with 4y equals 17z minus 12, or y equals 17/4 z minus 3. So now what I've done is I've got y isolated. I need to go back and plug this stuff here into this equation so that I can solve for my x and z values. So to do that, I have x minus 17/4 z minus 3 plus 4z equals 3. And if I go through and multiply everything by 4 in order to cancel out my denominators, or actually better yet, instead of plugging this stuff into this equation, we might as well use this where everything's multiplied by 4. And the reason I want to do that is because I see I have 4 times y, which is going to cancel out this denominator here. So let's get rid of that and go a negative 4x minus 4 times 17/4 z minus 3 plus, minus 16 z equals a negative 12. So when I distribute and simplify, we end up with a negative 4x minus, these are going to cancel, so that gives me 17z plus 12. This up here should be a plus, which will make this here a plus, and then this here stays a minus. So this should be minus 12 minus 16z equals a negative 12. So we go ahead and get our like terms. We have like terms here. I end up with a negative 4x plus z. I move this 12 over, and that gives me equals 0. So now I can solve for z, and z equals a positive 4x. And we said before that when we're doing our coordinate point, we're going to plug in a when we look at z's. So now I really have 4a, and if I plug in an a in for my y, or up here, I have 17a, or I'm sorry, z is equal to 4a. So if I go 17 fourths times 4, so let's write this, 17 fourths times 4a, and I'm getting that because of this right here, or what I've got here, minus 3. My 4's are going to cancel, and I'm left with 17a minus 3. And my x then, if you notice, we've been plugging in an a for x, so I'm just going to plug that in there. So this right here now is my final solution to my non-square system. So now to take a graphical look at what we're looking at when we look at our numbers of solutions, if I have something that has one solution, or I'm able to calculate an x, y, and z point, that means that all three planes, and you can see the pink, yellow, and blue, are going to intersect at one point. When I have infinitely many solutions, all of them are going to come together and meet and generate a line, or they could all be the exact same plane. And if we calculated something where we had no solution, notice we'll get something like this, where you might have two equations that are equal to one another, but not all three in the same system. And another scenario that would generate no solutions would be if all three planes were parallel, because there would be no intersections whatsoever. Next, let's look at example 5, which is going to deal with our vertical motion model. Now it says the height of time, or at time t, of an object moving in a vertical line with a constant acceleration a is given by s of t equals 1/2 at squared plus v sub 0 t plus s sub 0. Now our height, which is s, is measured in feet, acceleration is in feet per second squared, time is in seconds, and our velocity, or initial velocity, is in feet per second. And our initial height, or the height at which our object is launched from or released from, is also measured in feet. So what we want to do is we want to find acceleration, velocity, and initial height, given that we have a height of 52 feet at 1 second, 52 feet at 2 seconds, and 20 feet after 3 seconds. So the best way to approach this is to set this information up into an equation that directly correlates to that right there. So when we look at time t equals 1 second, we're going to have 1/2 times a times 1 squared plus v sub 0 times 1 second plus s sub 0 is going to equal 52 feet. And again, I got that from plugging that into this equation here. Then, when t equals 2, we have 1/2 a times 2 squared plus v sub 0 times 2 plus s sub 0, also, which equals 52. Then for t equals 3, we have 1/2 a times 3 seconds squared plus v sub 0 times 3 plus s sub 0 equals 20 feet. So if I go ahead and I write all of this as a system of equations, what I'm going to do is I'm going to eliminate this 1/2, so I'm going to divide all of these terms by 1/2, and which is the same thing as multiplying by 2. So that will give me a plus v sub 0 plus s sub 0, 2v sub 0, because I'm multiplying everything by 2, equals 104. Now in this case, everything's going to work out nicely for my second equation, because 1/2 of 4, because I have 2 squared, is just going to give me 2a plus 2v sub 0 plus 1s sub 0 equals 52. And when I get down to my third equation, I have 3 squared, which is 9, divided by 2, so I am going to want to multiply everything by 2 just to clear that out. So now that's going to give me 9a plus 6v sub 0 plus 2s sub 0 equals 40. So now I have three equations, three unknowns, which is a square system, and now I have to go about solving for this. Equation 1 is good, and remember this is R1, R2, and R3. So if I come over here, I'm going to leave that as A plus 2v sub 0 plus 2s sub 0 equals 104. I have my coefficient of 1 on my first term. Now I'm going to have to come up with a new second equation. So to do my new second equation, what I'm going to do is I'm going to go a negative 2r1 plus r2. So that gives me negative 2a minus 4v sub 0 minus 4s sub 0 equals a negative 208. And I'm adding that to 2a plus 2v sub 0 plus s sub 0, which equals 52. A's are going to cancel. I have a negative 2v sub 0 plus, minus 3s sub 0, and that's going to give me a negative 156. So I'm going to come and write that in here. I have negative 2v sub 0 minus 3s sub 0 equals a negative 156. I have to come up with a new third equation. So to come up with a new third equation, I'm going to eliminate my 9, and I'm going to use that first equation with the third one. So in order to do that, I'm going to go negative, and I'm going to have to go a negative 9r1 plus r3. So that gives me negative 9a minus 18v sub 0 minus 18s sub 0 equals a negative 936. And I'm going to add that to 9a plus 6v sub 0 plus 2s sub 0, which equals 40. A's are going to cancel. Negative 12v sub 0 minus 16s sub 0, and that's going to equal a negative 896, and this is my new third equation. Minus 16s sub 0 equals a negative 896. So now I have a new R1, a new R2, and a new R3. If I multiply my R2 equation by a negative 6R2 and add it to my R3 equation, we end up with 12v sub 0 plus 18s sub 0 equals 936. And then I have my negative 12v sub 0 minus 16s sub 0, and that gives me a negative 896. V's are going to cancel. 2s sub 0 equals, that'll give me 40. So s sub 0 then is equal to 20 when I divide. So now that I know what s is, I can actually go back and just back substitute. So in order to solve for v sub 0, let's do this as a semicolon. I'm going to plug in, and I'm just going to go into my new second equation. So I have negative 2v sub 0 minus 3 times 20 equals a negative 156. So this tells me that v sub 0 is equal to 48. And now that I know what v and s are, I can plug this into my original equation up here. And a then is going to be found by taking a plus 2 times 48 plus 2 times 20 equals 104. And if we solve for a then is going to give us a negative 32. So now, in order to write my model, we have S of t is equal to a negative 32 t squared plus 48t plus 20. So what this all means then is I have negative 32 feet per second squared, which is the constant, or the gravity due to acceleration. This is my initial velocity that my object was being thrown at, and this is the initial height, or 20 feet, at which my object was released. And last but not least, you will see a problem like this on your test. You'll see one on a quiz, you'll see one in your homework. So please make sure you can do these problems. If you can't, you must come and see me. Example 6 says that you're given inheritance money of $12,000 and you invested it into 3 accounts: a money market at 5%, municipal bonds at 6%, and a mutual fund that paid 12%, all of which were paid annually. The amount invested in your mutual funds was $4,000 more than what you invested in your municipal bonds, and the interest earned during the first year was $1,120. What we want to find out is how much you put in each one of the accounts. So the first thing I'm going to do is I'm going to go and mark with an X, Y, and Z what each fund is. So money markets are going to represent X. Municipal bonds is going to be Y, and my mutual funds is going to be Z. So now anytime I mention X, Y, or Z, this is what they correspond to. And 9 times out of 10, you are going to have some equation that's going to come up with your total amount of money invested, and that's going to be the amount of money that was invested at X, plus the amount that was invested at Y, plus the amount that was invested at Z, and that should give you your total of $12,000. Then you are given a total interest rate of $1,120. Well, to come up with an interest rate, you have to multiply the amounts invested at each interest rate. So you had a 5% rate, or 0.05x, plus a 6% rate, or 0.06, invested at Y, plus 12%, or 0.12, that was invested at Z, and when you add all those together, you should get $1,120. Now, the last equation is probably the most tricky. It says that the amount that was invested in mutual funds was $4,000 more than the amount invested in municipal bonds. What we have to do is we have to set that up as an equation. The amount that was invested in mutual funds, and remember, mutual funds is what you were calling, what do we call that? Z. So we'll say Z is equal to $4,000 more. So I have $4,000 plus the amount that I put in my municipal bonds. Well, municipal bonds we called Y. So now I have to get this equation here so that it looks more like this format. So my variables on one side, constants on the other. So I'm going to rewrite this as a negative Y plus Z equals 4,000. So negative Y plus Z equals 4,000. And now I've generated my system of linear equations. So now, in order to go ahead and solve, I'm kind of on the right track, which is nice. I have one equation that has a coefficient of 1 on X here. I have another equation which could technically be moved up to the middle, but I have a coefficient of 1 on my Y. Now all I have to do is get rid of this so that if I can get this equation down to Y's and Z's, then I can add it with this one, and then I can solve for Z and then back substitute. So in order to do that, what I'm going to do is I'm going to add, looks like if I multiply my first equation by 5, so I'm going to go 5R1 and we'll do that as a negative. And then I add that to, I don't want to deal with decimals, so I see that each decimal is to the hundredths place. So then I'm going to multiply my second equation by 100 R2, and this is going to give me a new second equation. So when I do this, what I end up with then is a negative 5x minus 5y minus 5z equals, and this is going to give you a large number, but negative 60,000. And I'm going to add that to 5x plus 6y plus 12z equals $1,112. We add these up, our x's go away, I'm left with y plus 7z equals 52,000. So now I have a new second equation. If I add this equation here to this equation here, then I can see that my y's will cancel and I can solve for z. So I have y plus 7z equals 52,000 and negative y plus z equals 4,000. We add these together, y's cancel out. 8z is equal to 56,000, which tells me then that z is equal to $7,000. Then I'm going to back substitute, and if I plug that into this equation right here, I see that a negative y plus $7,000 equals 4,000. This tells me then that y equals 3,000. And if I plug that up into the first equation, I have x plus 3,000 plus 7,000 equals 12,000. So now I know that x then equals $2,000. So again, if I show this as an ordered pair, my final solution then will be 2,000, 3,000, and $7,000 into the three accounts. And last but not least, I've given you a scenario that I want you to set up but not evaluate, very similar to the example that we just did. I will be checking this in class tomorrow, and on that note, I hope you have a good night, and I will see you in class tomorrow. Thanks.